The Earth and the Sun are separated by 150 million kilometers. Regardless of the distance that separates them, both occupy the same dimension of time, which we call the present. The present is a tenuous two-dimensional blade, which we cannot apprehend in isolation. When you think about the present, you find yourself looking into your own past. Starting from the observation of the sky, our logical reasoning tells us that the sun emits a great amount of light and heat into space. However, the act of issuing cannot be directly measured. You see the end result, expressed in light and heat that impress your senses. It turns out that the sun is virtually isolated within its future light cone. At that place in space, time cannot be measured directly, which forces us to see the star through its messenger, the light. Through its limited speed, light tells us that the sun would shine 150 million kilometers from here. That is, it would be seen late and looking as it did 8 minutes ago. Thus, we evaluate the cause, sun, by its effect, radiated light. As there is no movement that can be measured in the absence of time, there is no way to prove that the light would have moved in space at a moment before its scattering next to us. Never mind that logic leads us to conclude that, yes, the light would probably have moved in space. Since we need the constant presence of its light to see the star late, there is a possibility that the light has always been around here, at least when it comes to our point of view. In addition, the start of the timing would be shifted from the star's position to the position of each of us. It is seen that the light would only move when it was already inside our past cone of light, or after the apparent inversion in the direction of the arrow of time. In reality, there would be no reversal, for the future would not have happened yet. What exists, for all intents and purposes, is what would already be found in our past. As we need to wait for the messenger to deliver his packet of information, it would be reasonable to think that the present of the universe, which cannot be retained in isolation, would be getting mixed up with the very concept of the future. For any celestial body to be seen in the night sky, it must first emit light or be illuminated. In this case, the future would result from only being able to look at the present moment of these stars, always late. This problem would be created by our memory, since, by definition, it depends on time in the past. Not coincidentally, the measure of time that separates us from the stars depends on the constant presence of light. Astronomers' future cone of light model predicts that the start of the time count would be placed at the position of the sun, where the light would depart. Thus, even without being able to measure the event directly, they abstract that light would travel through space from our future, or inside a virtual light cone. Indirectly, it is concluded that the light used to assess time would need 8 minutes to reach Earth. There are serious problems with this form of evaluation, as it neglects the influence of our memory on the interpretation of events. This memory tells us that the space would depend on a messenger who could communicate to us, with delay, the events in which this space was involved. To be noticed, light would need to assume some density, the shape of a cloud of particles. This process is known as quantization, and is equivalent to packing the light, which will result in the photon being scattered by the affected particle. Let's look at the concept of the future light cone of events. If we could measure time in the future directly, we could say that light waves would travel through space, from the source, forming concentric circles. That is, there should be some time separating the waves from each other. Physicists assume that light waves would depart from the sun at the same speed of 300,000 kilometers per second. The event is comparable to the circular waves which would be formed when a stone is thrown on the surface of a lake. If we knew the module of time retained within the future light cone of the Sun, the light waves could be superimposed on each other, moving away from the source, and resulting in the formation of a straight cone, called from the future. In this case, space in the future would gain depth. It is known that this would result from mere abstraction, as what was happening at this moment, in our future, would not exist for us, since the future has not yet happened. Our serious error of evaluation would be to consider that the Sun would be occupying the zero mark of time. In this case, the star would need to have a memory in order to be able to express its point of view about time. For example, in the case of its sudden death, we would need to wait 8 minutes for the sunlight, acting as a messenger, to communicate the event. Despite the delay in the manifestation of darkness, it would present itself abruptly to the observer, as if the event had been instantaneous. Thus, the zero mark of time will always be close to the observer, regardless of the distances previously covered by the light. Furthermore, this landmark could not be moved from our position to the position of a distant star, except in theory. Taking this into account, the center of the universe would be where an observer endowed with a memory might be. The periphery would be nowhere. If we were to move in space, we would carry this zero mark of time in tow. We would always be placed in the present moment of the universe, while everything around us would be seen with the appearance it had in the past. For better understanding, let's look at some graphs. If the start of the time counting were always at our position, and not at the position of the Sun, the star would not be directly seen, being replaced by its image. This image would appear out of time. As time cannot be measured in our future, neither can movement of any kind to be measured in the direction of the arrow of time. In this case, our Sun should have a dark companion, from which its own image would appear shifted in time. Even so, it would be expected that there would be a gravitational interaction between the star and its own image. They would tend to merge or overlap over the center, but this tendency would remain suspended to infinity. It is known that the Sun is always seen 8 minutes late. In order for the circular waves of light to move away from the source, we would have to rely on time, acting as time with a third dimension of space. This is represented in the thickness, or depth of a cube. In A, we have the imaginary cube that would enclose time in our future, when light waves would depart from the source. Normally, this source would be considered to be our ground zero of time. The tip of the diagonal arrow, which would unite the star and the Earth, would point to the future, leaving our planet outside the future light cone of the Sun. The light, in this case, would be coming from the Sun's present, and not from its past. From the point of view of the observer on Earth, the real arrow of time should be pointing to his future. In diagram B, the Earth would have already entered the future light cone of the Sun. At this point, the star can be seen instantly, but the light tells us that there would have been a delay of 8 minutes due to its limited speed. The arrow of time is inverted, and its tip is oriented towards our past. Note that, at this moment, the perception of the probable existence of a dark companion to the Sun becomes real, as we see our star looking like it did 8 minutes ago. If we compare the time graphs, cubes A and B, we will see that the cat jump would be in the light's orientation, acting as a space messenger. It would have caused immense confusion in our scientific assessment, due to its intrinsic characteristics of isotropy. That is, in space-time light would no longer depend on the direction of its propagation. In cube A, the light tells us that it would itself be stretching from the source. Even though the superposition of its circular waves suggested the formation of a straight three-dimensional cone of light, the theory of relativity predicts that time should contract in a complementary way. So, even if space still had the dimension of depth in our future, when described by light, that space would remain virtually flat to the viewer. This was due to the complementary contraction of time, as it would be the basic element for the functioning of our memory. This virtual flattening of the sun's future cone of light would merge light and space into a continuous whole. This continuum would prevent us from knowing what would be happening right now in our future. Our memory is, now, dependent on time in the past. In cube B, the light would have already reached us in the present, and, now, it would already point, in an apparently continuous way, to our past. The Earth and the Sun remain in the present, but the star would be replaced by its image, as if the Sun were in the past. Cube B would represent our past cone of light. In the two cubes, space seems to have been forever jettisoned from our physical reality, replaced by its messenger. To understand the extent of the problem, the isotropy of electromagnetic radiation shows us that space would be described by light, not by itself. If space could speak directly to the observer, there would be no uncertainty in the position of the light source, or its speed. By being packed or coincised in the shape of the cube A, the light would have virtually fused with space. This would have resulted in the space-time continuum, which, as noted, would have nothing continuous. This was due to the timeless nature of the quantization phase, already demonstrated by quantum physics. The uncertainty of the position or speed of our Sun, as well as that of other stars, would have been ignored by science when it allowed itself to be subjected to electromagnetic radiation. Astronomers would have attributed disproportionate relevance to the Doppler effect of light. Even so, this behavior would be forgivable, because the isotropy, resulting from the apparent continuity of the waves, is such that the late effect has become part of our physical reality. It is the same case of the circular and uniform motion, which has held humanity captive over the centuries. You know that the actual motion of electrons in planets is elliptical. In practice, however, it is circular and uniform. Full stop.